Hi all, I'm Sarang. In this video, I will walk you through a data platform I built on AWS using Terraform. The idea is very simple. In most data engineering teams, you need a reliable platform where data can be ingested, stored, processed, and monitored. Instead of up this manually, I have automated entire infrastructure using Terraform and deployed it through GitHub Action. The platform includes Kubernetes on EKS cluster, Apache Airflow on AWS MWAA service for orchestration, and S3 data lake for storage, and CloudWatch for monitoring, all running inside secure VPC on AWS. So here is the architecture diagram of my whole uh, infrastructure. On the left, you can see a GitHub repo where our code lives. When I push the code, GitHub Actions automatically deploy the whole infrastructure on AWS, as you can see over here. I will explain you the authentication between GitHub Actions and AWS in a while. Inside AWS, everything runs inside the VPC. As you can see over here, this is a virtual private network I have created, and there are public subnets, private subnets. The public subnets have internet gateway to allow inbound internet traffic, and NAT gateway so that the components over here in EKS cluster or MWAA Airflow can communicate with internet via NAT gateway and download packages or required dependencies. So anything running over your Python scripts or your jobs, if they want something to be downloaded from internet, they connect to NAT gateway and then via that internet gateway and to the internet. In this private subnet, we have main two services. First is EKS cluster for offloading the compute of your Python scripts. Second is Airflow. So this Airflow is where our data pipelines run. Okay, the code for data pipeline runs over here, and we have capability to offload that processing towards EKS cluster. Inside Airflow, we have a component called as SQS, which you can see over here, and I have named it as Airflow Celery. So what is this SQS is about? It's Amazon Simple Queue service. When you trigger a DAG in Airflow, the AWS Airflow scheduler doesn't run the task itself. It puts them into this SQS queue, and the worker containers picks them and executes them. So worker containers will be running over here, but the DAG execution scheduler will put the task over here SQS, and when the time comes, the workers will pull the task over here and they will get executed. The task can run on the MWAA also, Airflow also. The connectivity between Airflow and EKS cluster is already established. So there, in case we have a lot of huge data tasks, then those we can run over here EKS cluster, and the connection between these two happens via something called as Kubernetes pod operator. Okay, so there are multiple components coming into picture when we are going to discuss about the Airflow to EKS cluster connectivity. First is the secret manager. Okay, and in secret manager, what we have is something called as EKS kubeconfig. So this EKS kubeconfig is kind of credentials to your EKS cluster. So the Airflow can access this, and then it can run anything which it requires to be run over here. Second important thing is EKS access entry. This is on the EKS side. In the Terraform code, I have created something called as EKS access entry. This basically maps to the IAM role of the Airflow. Here on the top, you can see we have created some IAM roles. One is EKS cluster role. Second is EKS node group role. Both are related to this. Then MWAA execution role. This is Airflow execution role. So this role is associated over here. And then GitHub OICD role. This role is associated over here. What is the use case of this third role? So this is associated with Airflow, and using this roles permission, Airflow can communicate with other entities. So cluster is one of the entity, and in order for this Airflow to communicate with cluster, we take help from this execution role. And earlier I explained you about access entry. So on the EKS side, I have developed access entry, which allows this IAM role to communicate with it. And the registration of this is kind of more detail. We can look into this further, like how this cluster communicates with, allows this Airflow role. So the role is registered as a MWAA dash user over here. And if we look further, then there is something called as Kubernetes RBAC. So inside Kubernetes cluster, we define role that allows creating, deleting, and watching pods. A role binding that gives MWAA user that role. This means MWAA, which is our Airflow, can do what it needs to do, like creation of the pods, monitoring of the pods, all those things. Okay. Fourth thing, as part of this connection configuration is ECR. Let's see. The ECR is over here. So the Docker images of our task are stored in Amazon ECR. When the pod starts over here on a node, it pulls the Docker image from ECR. Okay, so this basically acts as the image store repository, and it is the Airflow which pushes the images, new kind of images related to our DAG task over here. So the code, DAG code, Python code lives over here, and then it is the image associated with it is gets pushed to ECR. And when pod starts on the node over here, the Kubernetes node pulls the image from ECR and executes the same and sends back the result to Airflow. So whatever is the status of the job task. So in a nutshell, if I have to summarize how the communication between Airflow and EKS cluster happens, it's like Airflow reads the kubeconfig file from secret manager. Using that, it connects to EKS using access entry, and Kubernetes RBAC authorizes that entry. Then EKS node pulls the necessary task image from ECR and runs it. Okay. Now next part of this infrastructure is we have two S3 buckets. Yeah, 1 and 2, which you can see over here. Now what are these S3 buckets for? First S3 bucket is DAGs bucket. So here we store DAG files which are being read by Airflow. And other is the data lake S3 bucket, where the actual data lives either in the raw format or also output process format. Then we also have CloudWatch dashboard. Okay. So if something goes wrong, like AWS Airflow scheduler stops, an alarm triggers and sends notification to SNS, which is Amazon's simple notification service. SNS acts as a message broadcaster. In this setup, I have also registered email ID. So this SNS will forward that email directly to the engineer. Yeah, that's a short overview of my infrastructure over here.